Good morning everyone. So recall that in the last class we talked about Rook's polynomial, and this is the example which we discussed in the last class where we need to compute the number of permissible arrangement. So permissible arrangement means there should not be two letters in the same row or same column. Yes, and we need to arrange in such a way that none of the letters should get the darkened square. For solving this, we use the concept of inclusion exclusion principle, and the first step is to break the given arrangement into disjoint boards, something like this. Now how do you break this one? So you can see that this itself is one board, and then they are in the same row and same column. So we need to interchange the rows and the columns. For example, 1 and 5. So when 5 comes here, then this would be shifted here and this would be shifted here. And when you put E here and you put B down, so you can see that you put B and C down, and that gives you the two disjoint boards. Once you have two disjoint boards, then you compute for the board B1, you compute Rx B1, which is R0 B1, which is always 1. Then R1 B1, which is number of the ways to put a rook on board B1. So there are three possibilities are there. So 3x, and the number of the ways to put two rooks, so there is only one possibility here and here. Why not the other? Because in the other cases there would be two rooks in the same row or same column. So this is x square. Similarly Rx B2 you compute, so four possibilities are there, four positions, and then if you put two rooks, then this is one possibility, then this is 2, and this is 3, so 3x square. Then you multiply to have Rxb. So this is your Rxb. From Rxb, this gives you R0b, this gives you R1b, this gives you R2b, and so on. And if you substitute it into this formula, then this gives you the number of the permissible arrangements. Now let's see some more examples. So first read the question. It says that how many ways are there to send 6 different birthday cards to 3 aunts and 3 uncles with some restrictions. Aunt A1 would not like cards C2 and C4 and so on. So this restriction means that we have to use the concept of the Rook polynomial here. First step is to have the board. Now from the board we need to identify, again we need to form the disjoint boards. Yes, and I told you the way is, if you see this square, then there is no other rook in the same row and same column. It means it itself forms a single board. But now if you see these four squares, then they can be joined together, and the remaining three can be joined together. So this is how it looks like. Yes, so it means you can say this is my board B1, this is B2, this is B3, and the computation is easy. So 1 plus 4x plus 2x square for two rooks, this is one possibility and this is the other possibility. Then 1 plus 3x, there is only one possibility for one rook, and then 1 plus x, and this is Rxp. Yes, once you do this computation, then you have R0b, R1b, R2b, and so on, and they can be used to compute the number of the permissible arrangements. Let's try one more question. Now this is little bit more complex. The first step is to have the board. Now if you see this board and try to make the arrangements, then you will realize that it's not very straightforward. But few quick observation is, this is, there is nothing in this row and this columns, it's a separate board. Now if you see these two, so this one has only, here there is nothing, but here there is only one board, and for this one also there is nothing here. Yes, so it can be easily shifted here, and that's why it formed the one board. Now for the remaining one, there are 6 squares are there and you need to arrange them. Yes. So this arrangement is little bit tricky. So the first step is, I told you this two gone. Now I shifted this one to this position and shifted this one here. So these two would be clubbed, these two are already there, and these two. Now what I did is that I interchange M2 M1. So you can see here that M2 M1 got interchanged, and also F5 should be put here. So when you put F5 and interchange M1 M2, then this part would be generated. Yes, and the rest of the part is simple. This part is as it is here, and when you interchange the position, then this is how your board B1 would look like. So this requires a little bit of exercise. One important thing to remember is that when you form a board, then there should not be any empty spaces. For example, you cannot make a board something like this, and so all these are darkened square and there is an empty square in between. We do not call it a board. So board means that there is no empty space in between. So now board B1, B2, B3 are there. So this is your B1. So for B1 you need to compute, we may need it many times for the computation. Then this one and then this one. So 1 plus now the 2 rooks. So this is one possibility. Then this is 2. Then this is 3. Then this is 4. Now I start with this one. So this one is 5. Then 6. Then 7. Then this one 8. This one 9. And the last one is 10. Please do try it by yourself. So 1 plus 6x plus 10x square, but this is a special case where you can see that there are 3 rows and 4 columns. It means I need to compute R3B1 also. So if I put 3 rooks, the first possibility is I can say 1, 2, 3. So this is the first possibility. The next one is 4, 5 and 6. Then the next one is 7, 8 and 9, and then the last one is 10, 11 and 12. So total, 4 possibilities are there. Rest is easy computation. Rx b2 which is 1 plus 2x and Rx b3 which is 1 plus x. So you multiply them and that gives you the required Rxb. Now one quick observation is that when you do the computation for Rxb1, you may do some mistakes because the board is little bit larger than the previous examples, and that's why in the next class we have to see that if the board is quite large, how to break it into these smaller boards where it is not directly visible to break into the disjoint board. So something like this. So if you have board like this, you can do the computation by considering it as one board, but we will see the examples where how to break it into the disjoint boards. Okay, so that's all from today's class. Thank you.